Hello ladies, gents, and everyones. It is Thursday, January 20th, and we're here to talk about this week's space and astronomy news. So in our solar system, we know of over 200 moons, but we know of exactly 0 moons in other solar systems, or exomoons. This is because moons are really hard to detect. One possible method of detecting exomoons is to look for their signals with their planet as they transit the face of the star. But this is really tricky to do. As you can imagine, the geometry of the moon-planet-star system is going to change, and the moons are smaller than the planets, and the planet signal is already pretty small for transits. But astronomers think that they may have done it. The candidate is called Kepler 1708bi. That means it's star 1708 in the catalog of stars that the Kepler Space Telescope looked at, and B means that it's the first planet discovered around that star, in this case it's actually the only planet, and I means the nomenclature for the first moon around that planet. This study was published from a search of over 70 stars for an exomoon signal, and now the lead author has stressed that this signal is a candidate only, it's not confirmed. Now, if it does exist, the system is quite unlike any of these solar system satellites. The moon itself has a radius of 2.6 times the Earth's radius, and it's in orbit around a Jupiter-like planet. This is a really exciting announcement, and astronomers will definitely be trying to confirm this one. We have been sending humans to space for a long time, including over 20 years of continuous occupation of the International Space Station. But don't think that means it's a walk in the park. Space is a very unforgiving environment, and it's not one that humans are adapted for. Case in point, a new study that was just published in Nature Medicine showed that astronauts in space continuously destroy over 50% more red blood cells than they do here on Earth. Now, the authors think that this increase in red blood cell destruction is probably mostly offset by an increase in red blood cell production as well, otherwise the astronauts would have severe anemia while they're in space. But even so, many of the astronauts did actually have anemia when they returned to Earth. The study was conducted over 6 months, and it appears that this risk of anemia tends to increase for longer missions. This is definitely something to be concerned about, for example, for long Mars missions, both for the increased risk of anemia, especially upon returning from freefall, and as well as possible dietary requirements to support this increased production as well. Previously, scientists thought that this red blood cell destruction was a temporary effect as the body adjusted to a reduced blood volume in space. So this new finding just goes to show how much we still have to learn about humans and spaceflight. We have been giving a lot of love to Perseverance lately, and for good reason. It's still working on getting those pebbles out, by the way. But the Curiosity rover is also still chugging along over there, and it's that rover that we have to thank for the latest tantalizing discovery on Mars: carbon. Okay, it's not actually surprising that we found carbon itself. So elements are defined by the number of protons they have. Carbon has 6, but the number of neutrons can vary, leading to what we call different isotopes of an element. So carbon actually has 2 stable isotopes, one that has 6 neutrons and one that has 7 neutrons. These are called carbon-12 and carbon-13 respectively, thanks to their atomic weight. And what Curiosity found when it analyzed samples taken in the Gale crater is that there was more of the carbon-12 than was expected. Okay, so what? Well, carbon-12 actually has weaker bonds, which means that it's more easily utilized by life. This type of carbon-12 enrichment here on Earth would definitely be a sign of ancient microbial life. Now, this isn't to say that this is definitive evidence of ancient microbial life on Mars. There are some other possible non-biological explanations, such as interstellar dust or certain reactions with UV light and carbon dioxide. But it is certainly an unexpected and unusual signal, and the team who published their findings this week in the Proceedings of the National Academy of Sciences say that it inches up the plausibility of ancient microbes on Mars. By the way, if you're enjoying this video and you want to see more space and astronomy content, make sure to like and subscribe. I, like probably many of you, enjoyed watching Don't Look Up on Netflix recently. And an Earth impact is certainly a very real danger, although it's also currently a very, very unlikely one. Large asteroids are tracked by NASA and other organizations, and the Center for Near-Earth Object Studies currently estimates that we know of 90% of the NEOs that are larger than 1 kilometer, and none of them are going to hit us. So while it was never any danger, it is kind of fun to know that we recently just had a very close encounter. This was with asteroid 7482 or 1994 PC1, which is a pretty big boy, just over 1 kilometer in size. And on Tuesday night, it passed just under 1.25 million miles from the Earth, or about 5 times the distance to the Moon. Passing so close meant that it had an apparent magnitude of 16.6, which is quite bright for an asteroid, but it would still require a pretty good-sized telescope to see it, maybe 15-inch aperture or so. A lot of amateur astronomers were able to see the passage, which is just really cool, and I just think it's pretty damn cool to know that there was a rock the size of a skyscraper that just hurtled by us at like 40,000 miles an hour. Cool. Lastly, let's get another quick update on the web. Things are definitely slowing down for JWST as it is preparing itself to become ready to take observations. I mentioned last week that all of the mirror segments and the secondary mirror were moving from their stowed launch positions into their operational positions, and as of yesterday, that process is complete. Now that the mirrors are in this deployed position, they can start to make the really fine adjustments needed to get the proper alignment for the mirrors. This alignment is going to take about 3 months, so we have plenty of time to be good and patient while we wait. And this weekend, the observatory should be making its L2 insertion burn. This is the last step before the telescope is on location and ready to go. And by ready to go, I mean ready to cool down, align the optics, and calibrate the instruments, and hope of first light within the next few months. Also, a lot of you have asked what the JWST is going to be looking at first, so stay tuned for Monday's video where I will give you all the deets. Well, that's it for this week. Thanks so much for watching, and I'll see you again next week. Bye!